The USS Mackerel was built in 1953. The U.S. Navy originally designated this submarine as an auxiliary submarine, AGSS 570. Didn't have any weapon systems or fire control systems. It was just a simple testing submarine, auxiliary submarine. But before they had even finished it, she had been redesignated as a training submarine, SST 1, or as it was known to be called, USS T1, and she was destined to become an ASW training vessel for the United States Navy. But in 1966, her world changed for a short period of time of about 9 to 10 months. She became a special equipment testing platform for keel mounted wheels, thrusters that could maneuver the ship within the length of its own body, and a manipulator arm on the bottom that could pick up objects. All this equipment would eventually be installed into the NR-1. This is the NR-1 Nerwin subbrief. Let's take a minute to thank our sources first. All right, our story begins with the USS Mackerel, and in the 1960s, Admiral Rickover learned of the Ivy Bell missions. Now, the Ivy Bell missions were happening with the USS Halibut and then the Parche later on. They were doing different things over on the Pacific side of things, where they were tapping into communications, undersea communications, and Rickover wanted to have a submarine that could do that on the Atlantic side. So he worked with scientist John P. Craven, who was part of the special projects of Bureau of Ships, and he also worked on the USS Halibut and was familiar with the program. So together, they designed a nuclear-powered deep submerged submarine that could conduct these special operation missions, but without divers. The Parche and the Halibut, they all had to have divers in the water, doing these operations. They wanted to build a submarine that could do it independently with everyone inside the submarine the whole time. And together they raised about $32 million to construct a submarine to do just this. So these are the two engineers that came together, an admiral, nuclear engineer, and the chief scientist with a history in special projects coming together to build NR-1. So here's how this happened. Rickover funded his own project without going through the normal chains of command. He had done this before whenever he was pretty much pushing nuclear power into the U.S. Navy. Instead of into the surface Navy, he pushed it into the submarine Navy without really telling anybody until it was already in progress. Well, he did something similar here to fund this NR-1 idea. So this all kind of begins with the loss of the Thresher off the coast of Massachusetts during sea trials in 1963. That loss of life of over 120 some young souls led to the development of a deep submergence submarine project, or DSSP. The DSSP would build rescue vehicles. And so the DSRV was created to go down and dock with a stricken submarine and bring the crew up, about 10 crew members at a time, over multiple trips. But special projects that built this DSSP and DSRV had a secret budget, much like the CIA's budget is secret. Special projects in the Bureau of Ships budget is secret as well. And who's in charge of that money? John P. Craven, the guy that was working on modifying the Halibut and working on those special missions. So special projects works in the Bureau of Ships, where Admiral Rickover works as well. Now, Admiral Rickover, he is the assistant chief to the nuclear propulsion part of the BU ships. So he's really high ranking up there. He is higher than Chief Scientist Craven is. Admiral Rickover is also the manager, or a manager, but the manager over at Nuclear Reactors. The nuclear reactors is part of AEC, Atomic Engineering Commission, of which he sits on a committee, which is above Bureau of Ships. So Rickover has two positions, one on a committee that oversees many different things, anything to do with nuclear power, including Bureau of Ships. So he has two positions in a chain of command, one subservient to the other one. So Rickover could order Bureau Ships Admiral Rickover to build a nuclear research submarine, and BU Ships could not refuse, as long as it didn't involve any other departments, and this was kind of key. So he very strategically built a research vessel submarine that didn't have any weapon systems on it and had no combat capabilities and was going to be used strictly in the special projects program as a non-commissioned research vessel. These are all very key words that keeps the program strictly in line with the Bureau of Ships and not involving any other part of the DoD and evading eventually all those other oversights and inspections and committees that can get involved in building and improving a ship, because each one of those has their own little budgets and committees and bureaucracy that takes a lot of time. Well, he was skipping all that by making a very narrowly focused submarine and funding it by himself. So with the Bureau of Ships, he had approximately $22 million that was already designated towards other projects. So other ships, other submarines that were going to be built on both coasts. He's taking a little bit of money out of a lot of different projects and he assembles a bucket of $22 million. And he takes this idea to special projects and says, how much money can you give us? He basically steals John P. Craven out of the special projects program that he's working on with whatever's going on in there and brings him into the NR-1 program with $10 million more. And that's how the NR-1 program began, with a budget of approximately $32 million, started by essentially two men. Now, you cannot build a submarine and crew it and have it be supported in the United States Navy at shipyards and maintenance without telling people. So he did need to go to the chief of naval operations, the senior admiral, and tell him what was going on eventually. But before he did that, he went to his friends in Congress first. Because remember, Rickover, he got promoted through a special congressional committee because people in the Navy did not like him. They don't want to promote him. So again, he's kind of greasing the approval by going around the chain of command, again, going to Congress first, whether it's at dinner parties or in private meetings and saying, hey, we're building this research vessel. We're funding it for ourselves. It's going to cost about 20% of what a normal submarine would normally cost, but because it's research focused only, it doesn't have any weapons on it, it doesn't cost hardly any money, and we've already got the money for it. So anybody he talked to in terms of like the Secretary of the Navy was already on board with it. So by the time he approached the senior leadership in the Navy about this idea, the Navy, even though they didn't like it and they wanted to cancel it, tell them, no, you can't build an NR-1. You need to be building our ships that we're paying you money for. The $22 million, where did that come from? And they want to know all these things. But because the Secretary of the Navy, he had already had him on board with the NR-1 idea, he kind of got around it. Also, in 1965, whenever this discussion is going on, what else is happening? Well, there's a little conflict brewing in Southeast Asia in a country called Vietnam. And Big Navy is not worried about Rickover's little dreamboat, NR-1. They're worried about carrier fleets, Gulf of Tonkin, things that are happening over there. So they're very distracted. They don't have the time or the energy to shut down another one of Rickover's pet projects. So this is kind of like the perfect storm of a very narrowly focused ship that's already funded, that's outside the chain of command or an oversight of big water Navy, blue water Navy. And that's how this got done. This could not be done today, but it was done perfectly in line with the Navy being distracted, congressional approval, pretty much preordained, and they weren't taking any additional funds from the Navy. But of course, the ship is eventually going to need a crew. It's going to eventually need an overhaul, and those things will be done in this ship. But the ship will not be commissioned. This is not a commissioned vessel. Much like the USS T1 or SST1, it's going to act as a special project ship or a research ship, not a commissioned naval vessel. All right. General Dynamics is where it's built in Groton, Connecticut. They designed and built her in the 1960s. There you can see a photo of her alongside a 688 class submarine. 688 was where I spent most of my naval career. I can tell you 688, 130 guys on that thing. It's pretty small. It's pretty tight. This thing is about maybe less than half the length of a 688 and much less than half the width. So Rickover required that any civilian engineer that is going to work on this thing and build it in the dry dock, they go to the U.S. Navy Power School, of which he was head of, for a year before they could even begin working on anything. So engineers in Electric Boat that were already building nuclear submarines, working on nuclear reactors, had to go to school again, before they were allowed to touch anything on the NR-1. This is just one of the requirements that Rickover seemingly arbitrarily put onto the construction process. Now, in terms of material, this submarine has a nearly perfect round hull. It's made out of HY80 steel, which is the same steel used in the 688s, which is it's a special kind of steel used for submarines and some other projects, but mostly submarines. But it had to be almost perfectly round so that it didn't collapse from the pressure, because this thing is going to be designed to go down to approximately 3,000 feet. It's going to work without divers, so it's going to have some external, tools like a manipulator hand, and it's going to have a basket where the hand can pick something up and put it in the basket and then bring it up to the surface together. It has a miniature nuclear reactor. This thing, no kidding, is approximately the size of a small refrigerator. So if you go into your kitchen, look at your refrigerator, imagine if that was a nuclear reactor. The whole thing, like the primary loop, the secondary loop, the whole thing is just kind of creating a very small amount of energy that can then be converted into electricity with a turbo generator. So we call this a nuclear reactor turbo generator power plant. One of the only of its kind. Well, it's certainly the only one of its kind, because it only made one NR-1 and it was specifically made for that. But a nuclear powered turbo generator in itself is a little unique. It has 3 viewports along the bottom forward part of the ship that looks out at the bottom, where a sailor could lay down, and he only had enough room to lay down for these viewports, and look at the bottom through this 6-inch thick piece of glass. It was that thick because it had to withstand all the pressure. And it was only maybe 4 or 5 inches around. It was thicker than it was large. Then you could view through it. So as this submarine is rolling along with wheels on the bottom of the ocean, you could have a couple sailors look through these viewports and look for items to pick up. So here's some pictures of the external tools here. They had a mechanically jointed arm that could lift 250 pounds. There's a picture of it there on the left. It's got a little orange clamper. It had a little basket that it would, after it picked something up, it would place it in the basket. The basket kind of dropped down from in front of where the viewports are there, and would raise back up again. It had 2 rubber wheels mounted in line like a bicycle. The first time they submerged, they took Goodyear tires, like the kind you would put on your truck. And of course, they collapsed from the immense pressure. So they had to go back to Goodyear and get special tires made. There was a lot of animosity with the NASA Apollo program because they were putting moon buggies on the moon laced with diamond treads, and so they had special tires for the moon buggy, but they couldn't get special tires for this project because there was a lot more visibility in the Apollo program than there was in this program. It had both black and white and color cameras mounted all around on the bottom side, and then also on a periscope-like device, and multiple external lights. Both like floodlights and incandescent lights. It could basically just light up the bottom, record it on video, and you had viewports available to the crew members as well. All right, so SPERRY Marine Systems made a lot of the controls, electronics, and computers for the NR-1. Their office at the time was located in the Charlottesville, Virginia area. They built and tested the computers that would run the NR-1. They also built a really cool flight simulator called a ship's control or sub-control simulator, where the crew could come and practice driving the submarine before they actually did it. They also designed the con, so that's where the sailors sit and drive the submarine and manipulate the cameras and stuff. They designed that entire cockpit-like area. They programmed and create the Yuck 44 computer. That's it right there on the right. It has a black, rectangle-like vent on the bottom, and then the top black part, that's the display part up there. And yeah, they had to program it in machine code. It didn't have an operating system. So whenever you're loading memory registers, you're literally loading it in with 1s and 0s. Yeah. We had the Yuck 44 on the 688. We also had the Yuck 7s. And whenever I was loading my sonar system, the sonar system didn't have a BIOS like your computer at home has. You had to load the BIOS commands manually with machine language. So you would select register 1 by hitting, the button that meant 1, because it was either 1 or a 0, and then that would light up an 8-bit register, and you would program the 8-bit register with 1 value. And you would repeat this process approximately 60 to 75 entries. And you had to memorize these to boot the computers up. Yeah, you were literally loading registers one machine language value at a time. For a sonar system on the 688, it was approximately 60 values. And you had to memorize this to be a sonar supervisor. And some people could never get it down. I was fortunate enough to be able to memorize it. And that's the kind of machine programming that they're putting into the Yuck 44. They had very limited memory, a limited number of commands that they could execute, and it was linear, so it had to execute one command at a time. So they had to be careful not to overload this little computer with too many commands. All right, so it had a high frequency collision avoidance sonar. That's You'll see that in the next slide, but it's like a forward-looking and a side scan sonar where they could search for objects and then avoid, of course, running into like the side of a mountain or the side of a sunken ship or something. The side scan sonar could look out to approximately 1,800 feet. It has different modes with different ranges. So here in this picture, you can see the pie slice, like forward-looking part of the high-frequency sonar. Those displays, as you're looking at them now, are in passive mode. That is not active. I assume the active is still secret, so I'm not going to talk about it. But since they're showing you the passive, do you see how the background for this part of the screen here is blue, where my cursor's at? Well, that means low background noise, nothing there. Blue representing clean water. But these green spikes, these green areas, that means that there's a rise in noise in that direction. So you've got something making noise there. Now, obviously, shipwrecks that have been on the bottom for years don't make a lot of noise. So there is also an active mode where that thing kind of pings out. Imagine like from the movie Aliens, those motion sensors that pinged, very similar to that. Yeah. And, but we're not going to go into how the active one works. You see a lot of the TV cameras that they have here are mounted on the bottom of the submarine, and there's even a periscope TV camera. This is one of the first American submarines to use a TV camera as a periscope. Yeah, very cool design. So the con, as we come to call it, changes over the years. It has multiple upgrades, and so these are some of the different configurations that the con was in over the 40-year period of the submarine's operation. Here at the top, you see a lot of danger tags hanging. These are valves that are locked in a position so that they can do testing and work on systems without spewing high pressure air or hydraulics all over the place. It allows you to work on systems without draining the energy out of the systems unless you need to. Oh, and this right here, this is the Yuck 44 computer. This is an air vent. The air vent is larger than the computer itself because this thing made a lot of heat. This thing was like a space heater whenever you walked by it. Yeah, and this keypad here and these little toggle switches, these are how you would program the registers. Yeah, very, very old school programming. Kids these days with their keyboards and mice. All right, the first crew. Every crew member and officer had to graduate power school. So that didn't just apply to the people building the submarine. If you were going to be on the NR-1, you had to be a nuke. You had to have graduated from nuke school. Every submarine officer in the submarine force for the United States Navy is a nuke graduate, but not every enlisted man is. Only the people that work in the engine room are nuke graduates. So every one of these crew members were Navy power graduates. And that kind of made me jealous because I saw the NR-1 parked next to my submarine for years and I wanted to get orders to it, but I was never eligible in my entire career, only because I never went to nuke school. But every one of these guys, as young as they look, they are extremely intelligent, no matter what color shirt they're wearing, whether they're an officer, an enlisted man, or an engineer, or the scientists that go underway. These are a bunch of very incredibly intelligent people that man the NR-1. They're individually screened. Every crew member is individually screened throughout the entire program. January 25th, 1969, the NR-1 is launched into the Thames River. There it is, being christened by Miss Robert W. Morse. And so the keel was laid in 1966. It was launched in 1969, so approximately 3 years to get it launched. It's, again, never commissioned. It's very important that you don't commission this boat because the moment you commission it, it falls under the umbrella of a lot of other departments other than the Bureau of Ships. So it's going to be launched, it's going to go do sea trials, and then it's going to disappear into the Special Projects Program. All right, so here's the Naval Reactors 1, NR-1. It is 148 feet long, 13 feet wide, has one miniaturized nuclear reactor, 2 propellers, 3 blades each, 4 ducted X-mounted thrusters. It can make about 5 knots on the surface or about 4 knots submerged from the 2 3-bladed propellers. This submarine will be towed everywhere because if it's such slow surface speed, it just basically has a support ship with it every time it goes anywhere. And so it gets towed at about 15 knots or whatever the speed is. It's usually about 15 knots out in deep water. Oh, and whenever it's being towed, it submerges itself. That's right. Once they get out into deep water, this thing will get tossed around by the big waves of the ocean. So they'll submerge to about 150 feet while being towed. Yeah. So you'll see a ship with a tow line coming off the back, and that goes right down into the water. And then down there, the submarine is more stable underwater, and it's safer actually for them to operate. Of course, the reactor is critical the whole time. It's providing electricity for the boat, but it's still going to be submerged as it's being towed. Okay, test depth 3,000 feet and 25 days max endurance with a 13-man crew. So a few notes about that. They had to eat basically microwavable meals. They did not have a microwave. They had a convection oven that they borrowed from the P-3 Orion airplane. They put that on here as the only way of making food. It was this convention oven. It would heat up the meal and you would eat it. So they didn't always have all 13 members on board. Sometimes they did, but they didn't always have that, especially whenever they were being towed and transiting. They would maybe have 9 or 10. Because they didn't need the scientist or whatever. So, but if the full complement of the crew, they could last up to 25 days. But it's a very crowded submarine for food for 13 people for 25 submarine. Because we'll show you right here. The crew could really only use half this already small submarine. So let's take a look at this from, say, the aft end, the rear end, going forward. So you got your 2 3-bladed propellers back there, and then you've got your stern thrusters. These thrusters are in an X configuration, blowing up and to the right, down and to the left, and vice versa. This allows the submarine to hover in place and spin around without actually moving anywhere. These thrusters are very cool. Just forward to that is a lead shot dispenser where tons and tons of lead shot were held as ballast. And so in the event of an emergency, if they just could not get to the surface, they could always release this lead shot, giving the submarine a lot of positive buoyancy and rising it up to the surface. Just forward to that, you see the first one of the 2 wheels on the keel. Above that is the engine room. The engine room is still secret. We're not going to talk about the engine room in detail other than that it did have a very low power reactor. You could imagine this reactor creates about as much energy as a diesel engine, like a diesel engine in your car or truck. It's not very high powered at all, but it is nuclear. That's important. All it does is it makes enough energy to turn a turbo generator that creates electricity, and everything, including the propellers, are turning on electric motors. Everything's electric here. So the only thing a reactor does is make electricity via the turbo generator. All right, we have some variable ballast tanks in the keels between the 2 wheels. The variable ballast are used to flood and drain seawater to kind of trim the ship, to give it a neutral buoyancy while submerged so they can maintain depth. Just forward to that is the lead shielding. So the one unique thing about this miniaturized nuclear reactor is that it did not have any shielding around the reactor itself, which is extremely unsafe. And unlike the United States nuclear program, as safe as it is, there's shielding on everything except NR-1. In order to save weight, because again, this thing is already only doing 4 knots. If they put any more weight on it, it won't be making any headway at all. So they had to remove as much weight as possible. So they put one lead shield between the forward compartment where the crew is and the engine room. This essentially makes the engine room, the entire engine room, a reactor compartment itself. Nobody is allowed in the engine room when the reactor is operational because there's no shielding in there. You'll go in there and get radiation poisoning. So the crew could only stay in the forward 1/3 of this already very small submarine. There it had 4 racks stacked one over the other. And this is officer berthing, enlisted berthing. This is everybody's berthing. Everyone's sharing a rack, even the captain and the XO. And yeah, you only had 3 officers on this thing. So, nobody gets their own rack. There's just no room for it. Everybody may have their own rack and stateroom on board the support ship, but on board the NR-1, certainly not. All right, the battery compartment is right there underneath the galley and the berthing area. We had the viewports up forward there, where they're right above the manipulator arm, looking out through the 3 viewports. Because of the limited berthing, crew members would often go down there to sleep, even though they're supposed to sleep in the bunks. They are often sleeping down there. That allowed them 3 more bunks, essentially, almost doubling the number of bunks on the submarine if they slept over the viewports. The mess hall, or the mess hall / wardroom / crew's mess, had the convection oven there, again borrowed from the P3 Orion program. Forward of that was the control station. So you essentially have 4 parts of the submarine if you count the viewing area. So you had the control station, the mess area, the berthing area, and then the little viewports where 3 guys could crawl down there and lay down and look outside the submarine. Very, very tiny submarine. Above that is a little space called the doghouse. The doghouse is the area between the pressure hull where the people are in and the sail bridge where the officer deck would stay when the submarine's on the surface. Because the United States Navy requires 2 valves, 2 watertight seals between the people tank, the pressure hull tank, and the outside, they had to have 2 hatches, one right over the other, to get into the submarine. So they had, it was called the doghouse, and it's this little area that you could crawl up into, shut the hatch below you before you open the hatch to get up into the sail. Forward of that is another lead shot dispenser. That's also where the basket is, where the mechanical manipulator arm would pick up items and throw it into the basket. The basket would lower down from just forward of it there. And then all the way forward of everything were 2 more bow thrusters in the X configuration, allowing the submarine to, again, maneuver around without moving forward, essentially. So a very small submarine, made even smaller by its weight restrictions. All right, the USS Sunbird, ASR-15 support ship. So I talked about the NR-1 being towed everywhere, right? So who was doing the towing? Well, it always had a support ship with it. This support ship was commissioned in 1950, and it was equipped with a deep diving bell. And the deep submergence operations that were designed for submarine rescue, but also, undersea exploration, research, it recovered a lot of Polaris missile items, also known as dummy warheads. So whenever the Navy was testing the submarine-launched Polaris missile, they wanted to recover as much of that missile as possible. They would send out the Sunbird to go and do those missions. But in 1969, all that stopped, and she became the dedicated support ship for NR-1. She would tow the NR-1 everywhere, all the way to the Mediterranean in one case, and all over the Atlantic, up to Scotland, down to the Gulf of Mexico, all through the Caribbean, where NR-1 spent much of her time was spent in the Gulf of Mexico and the Caribbean down there, because it's very shallow, clear, hard, sandy bottom, perfect for a little NR-1 to be rolling around on the bottom of the ocean. In 1990, the USS Sunbird was replaced by a charter boat called the Carolyn Shaw West, which was used as a support ship to the end of the NR-1's career. Oh, and I should mention again that while being towed, the NR-1, once it got into deep enough water, would submerge to approximately 150 feet and down there and just be towed along by the ship. And the reactor was critical during that time to provide electricity for the NR-1. So a very unique situation where submarine is being towed, also being submerged, and the reactor also being critical. Working as intended, but being towed underwater. So 1969 sea trials, here's Admiral Rickover. He personally oversaw every step of the construction, funding, operation, and of course, sea trials of the NR-1. And here you can see him climbing out of the doghouse into the bridge of the NR-1, where there's only room for maybe 1 or 2 people up there. So obviously the photographer and the Admiral in this case. On the right-hand side, you can see him sitting on the con with the control stick in hand, driving the submarine around. A really funny story about this photo on the right where he's driving the submarine is this is like day 2 of the sea trials. And Admiral Rickover is in charge of the sea trials. He doesn't necessarily have anything written down. He's just like, well, let's go down to 3,000 feet. Okay. And, just kind of making these things up as he goes along. Of course, he's got a plan. It's just not written down anywhere. So on day 2, the captain, the XO have all been up for like 2 days now. Everyone's getting exhausted. The captain refuses to go to bed because he wants to make sure everything goes smoothly. He's very, hands-on, which is fine. But Admiral Rickover says, "Captain, go get some sleep. I have the con." And whenever the admiral tells you that, well, the admiral has the con, you know. And so the captain did not want to go to sleep because he wanted to make sure everything was okay. He gets ordered to the rack, and he sits down with the most junior crew member, who's still a first-class petty officer, senior guy in the Navy, and kind of looks over at him and says, "Son, you can drive this thing, right?" And of course, the sailor's like, "Yes, sir. We've been in the trainer down in Virginia, so we can drive this thing around." So he sent the captain to bed, trusting that the crew member could actually perform his duties. And everything went fine on the sea trials. So one of the first things it did was very secret. And it's not very much of this is known publicly, so we're going to not talk a lot about it. But in the early 70s, NR-1 was instrumental in surveying the continental shelf off the coast of the United States and all the way down through the South Atlantic as well, to install or guide the Navy as the Navy is installing the SOSUS hydrophones. The SOSUS hydrophones had a very limited number of arrays and lengths that they could use. So they used multiple SOSUS hydrophone arrays all over the Atlantic and eventually the Pacific as well. But they wanted to optimize the location. Like, they didn't want to just lay down a string of hydrophones and hope that it worked. That's not how the Navy works. So they sent out the NR-1 to use its side scan sonar, map the bottom, and they took advantage of, surveyed canyons and natural topography to help kind of focus sound towards one location. And then they would put that array in that location. Now, the map you see here is not the array locations. Those are still secret today, and you'll never get them out of me. But what these are the control stations, the shore-based facilities that ran the arrays, ran the power to them, recorded the information from them. We're all the way down. We even had one, well, never mind. There they are. October 1976, she's pulled off SOSUS duty, and she's operating up in Scotland at that time for SOSUS, obviously duties up there as well, when there's a mishap on board an aircraft carrier off the coast of Scotland. This is attributed to throttle failure, so I assume a stuck throttle drove an F-14 right off the deck of an aircraft carrier, just right over the side. And they had weapons on board because they were prepping the plane for action. One of the weapons in 1976 was the highly secret at the time Phoenix missile. Phoenix missile was not public knowledge in 1976. This long-range missile that could knock bombers out of the sky from 100 miles away was not public knowledge as it is today. So they wanted to go down, recover as much of the craft as possible, but make sure you get this Phoenix missile, because the Russians have a very successful deep submergence recovery program already in the Uniform and the Paltus. They're off the coast of Norway every year collecting items, and that's very close to where this F-14 sank. So sure enough, they send in the NR-1 with a support ship Sunbird rather, and they go down, they find the airplane, they find the missile, they recover it, and here's a photo of the captain of the NR-1 and the captain of the Sunfish with the recovered missile topside. Look how happy they look. Anyway, great story of recovering some secret material off the bottom of the ocean that has been declassified now. In 1986, she's pulled off her SOSUS duty again to recover parts of the Challenger space shuttle that exploded during its launch into space in 1986. So a very macabre operation recovering body parts and equipment. But she did her role to help bring this investigation some clarity to find out what happened. And so she was, among other submarines, down there collecting parts. In 1994 and 1995, she's back in Key West. Like I said, she spends a lot of time in Gulf of Mexico and the Caribbean, including the Key West, which we had a base down there for a long time, so she would pull into that. But she found a large sinkhole in 1984. This was an unmapped, undocumented sinkhole that went who knows how deep. We're like, hey, there's a huge hole here, as they're doing other things. And then in 1995, they're ordered to go back and map the sinkhole. So this huge sinkhole, they take the NR-1 over it, and then they just submerge. They flood that variable ballast tank I showed you, and they slowly go down till they get close to about 3,000 feet, and they still don't reach the bottom. So they found this very large sinkhole off the coast of Key West, which is pretty cool. No one knew it was there, and it was right off our coast. That shows you how undocumented our oceans actually are, that it was that close to shore and no one even knew about it because it's under the water. In 1995, when she's done exploring sinkholes, she's towed over to the Mediterranean, where retired naval officer and oceanographer Robert Ballard uses the NR-1 to explore the wreck of the HMHS Britannic. So this ship is a sister ship of the Titanic. She was used as a hospital ship during World War I, where she struck a sea mine in there off the coast of Greece and sank there. Very sad story, hospital ship being sunk. So they explored and mapped the wreck with the side scan sonar, got very detailed computer drawings of it, as you see here, and a very successful operation. She also, while was in the Med, was asked to help universities find and document the location of Roman and Phoenician shipwrecks. And she was finding so many shipwrecks that they eventually asked her to stop because they had more exploration documentation than they could actually take advantage of. So if they had continued finding more wrecks, they couldn't have, they didn't have time to go out and pick everything up. So they were like, thank you very much for all the information. That's all we need from you right now. So she did a lot of really great work in the 90s over in the Mediterranean. All right. In 2008, she's deactivated from service after approximately 40 years, one of the longest serving submarines in United States Navy history, even though she wasn't commissioned. She is finally deactivated, towed to Portsmouth Naval Shipyard, which is on the East Coast up there in Kittery, Maine, tore apart. And then after she's tore apart, she's defueled. She's towed through the Panama Canal all the way around to Mare Island in Washington State, where she's then tore apart for scrapped. She doesn't have a reactor at this point, so she's just sitting there, just a bunch of metal. And it's in 2010, Congress steps in with a House Resolution 2647 and authorizes the Navy to preserve the NR-1 as a historical site, citing her contributions to naval research and exploration and oceanography. Everything she did in her career was pretty amazing, and it would be a shame to lose that. So they decided to save as much of the vessel as they could and bring it to the Submarine Museum in Groton, Connecticut. So she gets another trip, this time on the back of a truck, across the nation back to Connecticut, where she is now, at the Submarine Force Library Museum in Groton. There you can see them assembling all the parts and pieces. They saved the sail. They got the little grappling arm there, the propellers and the rudders all there. And it's very cool that they managed to save as much of that. It is really weird for me to see this as a museum piece, because I remember walking by it for years when she was operational to go to my submarine. You had to walk right by the NR-1. So yeah, it's just crazy to see it. I'm glad they saved it though. All right, so my final thoughts. Man, I'm a little bit all over the place on this one. So this is one of the few times, if you go back to the very beginning, where one person, a bureaucrat, this time I'm talking about committee member Rickover, made a bureaucratic decision to take action without sharing responsibility with anybody. If the NR-1 program had failed or gone terribly wrong, only one person was to blame, and that was going to be Admiral Rickover. He took a real risk. You don't see that anymore, anywhere. I don't know of any bureaucrat that will take action on a construction project worth millions of dollars that he's going to be the sole person responsible for. Everybody likes to make a decision by committee now in the United States bureaucracy, so that if something goes wrong, we can point fingers in all sorts of different directions. Well, Rickover wasn't having any of that. He's like, I don't want any of you guys involved in my project. I'm doing this. And it's one of the few times in the United States history that we get to see that in action, and it worked. It was great. This is one of the smallest nuclear reactors ever used on a naval vessel. This is similar to reactors that, in size anyway, that they put on satellites. Very, very small. It is an unshielded nuclear reactor, which made the entire engine room basically a reactor compartment. It is very unlike Rickover to do that. I'm sure he didn't want to, but it was a necessity because the small amount of power this reactor created. It was very, like I said, it's like a diesel engine in terms of energy that it puts out. Very, very small. So they had to save weight. And one of the ways they saved weight was by making the reactor less shielded. They didn't have any shielding on the reactor itself, on the vessel itself. All the shielding was simply between the crew compartment and the engine room, right there on that wall, lead shielding. Very unlike Rickover to do that. Okay, it had to be towed everywhere, which is weird since it was a nuclear-powered vessel, but it was only capable of 5 knots on the surface, and that's kind of rounding up a little bit. So in order to get anywhere within a reasonable amount of time, it had to be towed. But considering all that, it's still an engineering marvel that they made something so small, nuclear-powered, function for about 40 years. This is a great success story. And like I said, you can see it now. It's on display at the Submarine Museum in Groton, Connecticut. It's right off the main highway. So if you're ever driving through Connecticut on I-95, consider taking an hour or two out of your day to go by the Submarine Museum and take a look at this. It's really incredible.